So let's see here, and then I still have quite a laundry list of to-dos. So some of the long cycle modes, and I'll talk a little bit more about what a long cycle mode and a short cycle mode is with respect to 6847 here in not too long, aren't supported yet. So these are some of the intermediate high-res graphics modes, monochrome especially. There's some video quality issues on some VGA monitors. I did a mini plug fest last week and discovered that not all monitors are quite happy with the video signal yet, so I still got some work to do there. I still need to test SG6, SG12, and SG24. I suspect that once SG6 is working, that the other ones will just fall out. Because those really come from the SAM more so than an extra mode at 6847. Today we don't have 6847 T1 compatibility. I think Ed will probably have to make a different board just because of the pinout difference. The other major difference is that the latch that's normally on the older systems is outside the 6847. So when they pulled that in and added lowercase for the T1, right? Now it works a little bit different. And then production boards. So right now I think there's only 2 prototype boards in existence. Ed had one, I have one. Ed has already put together some production boards for the original 6847. I don't know if he has them populated yet. I haven't actually gotten one in my hands yet, but that will hopefully come soon. So yeah, some of the challenges that we've kind of run into along the way are variations in signal timing based on the clock edge used, power up clock edge used by the 6847. Right. This affects the artifact colors and things like that. So the way I deal with that is by actually running the FPGA at a much higher clock frequency and actually sampling both edges of the clock and actually producing a pulse on both the positive and negative edge of the 6847 clock. There are variations in the signal timing, depending whether we're doing long cycle or short cycle, so I've got to resolve that. And then up until I think 2 weeks ago, I obviously had a misunderstanding about how the SAM interacted with the 6847, and I'll talk about that particular bug just a little bit more here in just a second. So this is kind of the start of getting into more of the technical details. So talk a little bit about the differences between VGA and the CoCo style NTSC. So the pixel clock is considerably slower. You'd say, well, gee, why can't I just use a line doubler? Because you got 60 fields per second, 60 hertz refresh rate for a 640 by 480 VGA. Well, just line double it. Well, it's not really that simple, and part of that is kind of related to the pixel clock. So anyway, basically the half of the FPGA is running at this frequency and dealing with sampling this information, and half of it is running at the VGA output frequency. So what I did to try to preserve the black border is take in the basically double the pixels in each direction. So we get a 512 within 640 and 384 inside of 480, and the visible green field typically, right, and a black border around the outside. And then another aspect is, of course, that the CoCo runs at 5 volts and the FPGA only likes 3.3, so we have the level shifters. Let's see here. So back a couple years ago, this was how I probed. This is a 16K color basic CoCo 2. Not that it really matters, but here I've got basically a probe connected to the top of the 6847, and then all my probes run into my logic analyzer. And so I have some traces of the sort of data that I pulled off of this. So here's an example of a text mode capture. This is short cycle capture. I set up DD here, probably a little bit of an eye chart. I'll just tell you what's here. So I set up one of these rows to actually decode ASCII data. So this is 8 bits worth of data. It decodes it into ASCII. So what it actually says there as it's reading, so address 0 shows up 4 cycles later. You sample the data line. So C, address 1, 4 cycles later, sample to O, sample LOR space BASIC, right? Just like it says up there. So this, waveform basically happens, with horizontal sinks on either end, 12 times for a text screen, because there's 12 rows of pixels per character. This will happen 12 times, and then you move on to the next row of characters. This will happen 12 times. The same trace will happen. And then the decoding for the ASCII, of course, happens in 6847. So it knows what row it's on, and then therefore displays, the appropriate combination, mix of green or black pixels. Let's see here. Yeah, so I guess I should mention that, even though this was the first mode that I looked at, graphics data is generally simpler. Instead of having ASCII data here, you just have an 8-bit bit field that represent either color or, on or off information about, a handful of pixels that the 6847 wants to output. So this was the issue that I think, there's actually websites that talk about it since then that I was not aware of. But what happens between, so this is a full row of data. So here's horizontal sync low, so this is a full, full scan across the top of the screen. So you see here's address 0, counts up to hex 1F, so 32 characters across. And then the 6847 just keeps right on counting. You say, well, okay, that's fine, whatever, I can still sample that data. Well, only address 0 line goes to the SAM. The SAM increments its own internal counters. So once the 6847 address rolls over, it's actually reading the next line, and the 6847 doesn't know it. So what this was causing was a shift in pixels. You'd get the next row of pixels partway through the line up to address 9. So anyway, so I made a simple fix to basically stop storage after the 6847 rolls over. But anyway, and then going back to the long and short cycle stuff, this is a short cycle, like I said, it's 4 clocks. A long cycle, the address stays on here for 8 cycles, and then you expect to see the data 8 cycles after the initial address change. Let's see. So this is kind of the general board architecture of how it's laid out. You've got the PIA, and these are basically the mode bits that you poke either by using P mode or pokes or what have you. That set your color state, your graphics mode, and either alpha or graphics modes, right? Those are the VDG. You got the VDG requesting an address, and like I said, only address 0 goes to the SAM. SAM provides a full 16-bit address back to the RAM. RAM provides the data back. So basically what CoCoVGA is doing is it's sitting and watching the data going into the VDG, it's watching the address coming out of the VDG, and of course watching the board bits, and then produces its own VGA video from that. Oh, and I guess I should also mention, this kind of varies from system to system, but on the CoCo pins DD6, data 6 is connected to inverse, and 7 is connected to alpha versus semi-graphics. All right, and then this is the internal architecture of CoCoVGA, so if you could kind of blow up what's inside the FPGA itself. So here's all the signals that I'm switching, right? The frame sync, horizontal sync, data address, the different mode bits, and basically the sync generator and and the clocks basically tell the state machine inside the address data capture when to capture the data, and information about the frame sync lets it know whether it should write to frame buffer 0 or frame buffer 1. Basically, this is a ping pong buffer system where the idea is that you write into the frame that you're not displaying, and you display from the frame you're not writing into, because otherwise you end up with tearing, right? So, and then those get dumped out to the pixel gen module, and then that produces RGB. Pixel gen is the one that decodes, depending on the mode, it says, oh, I need to produce a text, or I need to decode the bits in there into color or particular pixels. So I think that's all I had. Thanks for attending. It's only been a kind of a very shallow dive. There's a lot more I could talk about, but I don't want to take everybody's time. So, just come by my table, or if you have some simple questions now, I'd be happy to take them. Boise, yeah.
So the final product will be a snooper, or will it be a total replacement of the CC?
We'll probably start by making the snooper available, just because it'll be available sooner.
Okay.
So folks with soldered 6847s will have to desolder and put in a socket. Yeah. The good news is that you can put your 6847 right into this board, so you don't have to piggyback on top of it. Right?
Will you have to make two variations of the board for the 6847 and the T1?
I believe so. It's been a little while since I've looked at the pinouts, but I think they're different enough that we'll probably have to.
But the advantage of the snooping too is that you'll be able to use the RF can as well as the VGA.
Exactly.
Okay. Thank
So
you. Awesome.
Ed is trying to talk me into the possibility of outputting the analog signal from the FPGA as well with a replacement, but I'm not keen on that. We'll have to see how things go.
Cool. Good work.
How about combining that with the ROM replacement for the character generator?
So that's another thing that I mentioned to Ed, and we actually talked about that a little bit. And one of the things we discussed was actually making the boards field upgradable. If you have a byte blaster cable and you're willing to download Quartus and build your own Verilog and stuff like that, or I can provide images on my website or something like that. Then people could upload it and actually change their font sets, and then you could select between them. So that's an enhancement that we're considering. So sorry, you had a question.
Yeah, if you do the double speed mode, does that make it go crazy?
I don't think so, but now that you mention it, I guess that's something I should test. I'll add that to my list. I'm glad you asked that.
Yeah. So the CoCo 2, that was the POC 65497, would make it go
Something like
crazy.
Yeah, because it screwed up the SAM refresh or something.
Yeah.
Yeah.
Right.
that.
Yeah, I'll have to give that a try. It's been a while.
So your block diagram, it looked like your address generation's one more before that, I think.
Yep.
Yeah, it looks like your CoCoVGA is not taking any address lines from the SAM.
That's right.
So-
And there's multiple reasons for that. One, the main reason is because I didn't want to have to probe the SAM and the VDG, right?
Right.
Basically, the easiest place to probe the VDG is at the VDG socket, right?
Yeah. But I mean, then you're gonna have to snoop the SAM accesses if you want to implement the same graphics modes.
Yeah, I'm guessing that, we may have problems with, SG12 and SG24 without knowing what the SAM is doing.
Mhm.
So I think that's going to be an issue. So, yeah, it's a valid point. All right, any other questions?
I think it was great.
Great project.
Thank you.
Good job.
Thanks.
I know it'd be a lot of work, but CoCo uploadable. I know it'd be a lot of work, but that would be good.
There's a lot of very
lot of
color changes, font changes, upload your own file set program and FPGA. Yeah,
Because this is gonna let me
there's
do
a ton of
fan tilt and zoom, and I get.
The hard part is getting it back like you had it published.
Oh, okay.
And I need to download the software to do it, so I've just done
Man, to
that.
remove the drivers will straighten.
Well, no,
So the
that-
FPGA
Well, at least you kept it here.
that you're using,
To get it back to normal.
you're actually generating a VGA signal